Hello, welcome to my video. In this video we want to see a C# simple HTTP server. First of all, we have a code, a simple code, but we need to know how HTTP works. HTTP is a network protocol for transporting a text. So this is work on network, but which protocol? HTTP 1 and 2 on TCP and HTTP 3 on UDP. So if we want to write a simple HTTP server, we need a TCP or UDP listener. We want to write a simple HTTP server, so we choose HTTP 1 because it's text and simple. But HTTP 2 and 3 is binary and but binary and complicate. HTTP 2 and HTTP 3 is binary and hard to coding. We need some additional package or something else. So see the code. First of all, we need a TCP listener. So create a socket, stream and TCP for HTTP 1. This TCP listener, we add some setting because if run the server and break it, if don't write this line, we need wait sometimes to operation system close the socket and allow to another program to use this socket. So we write this because of debug. Bind after that bind the socket to and IP to listen from any IP port 8080 and it's not important, we need to delete it, but I keep it and start listening. After listening some logs, and in the loop accept a client, this method accept a client through the no delay because is on network and delay is not good for keep live feature of HTTP, and process the connection in the task because we need multi-thread program and multi-client program and HTTP server. In the process the client, we need do some additional setting because in here we can write from socket and read to socket, but we use pipe. This is a C# class to write a binary data to memory because we need read data from the internet, and if our data or our connection be slow or client connection be slow, we have a latency in receive the data. So we are use the pipe to receive the data from the client and process it later. Okay, Back to process the connection. In here we create a pipe from the pipe pool, but it's something fantasy. We can use only this line, but I create a pool for pipe because if we want to create a pipe for each request, we have some additional task to do. But if we create a pool, we can use pipes for every request and rent a pipe from the pool, and after the process return it. So we can do less allocation in memory. So after the create a pipe or rent it, we need to fill the pipe and process it, because we need a task to read data from socket and get a memory, read from the socket and write it to a pipe and wait to complete and another tasks. It's not very important, and we need to process it. It's in this step we actually do HTTP1 process. Okay, in the process request we have a reader and writer. For now we read from the pipe but write into the socket, because if the client connection be slow, we need read it, but if my connection not to be slow, because you are the server, if the connection of server be slow, it's not good. So we read from the pipe and fill it in the background, but write in the socket. First of all, we have in HTTP1 keep alive feature. Keep alive feature give me and give the client feature to write multi HTTP request in the one TCP connection. So we don't need create a TCP connection for each request. So we check the keep alive, and keep alive by default is true, because in the HTTP 1.1 keep alive is true by default, and HTTP 1 false by default. So but in the most of requests in the network we use HTTP 101 1.1. So keep it true by default, and in the loop check the keep alive, because if keep alive is true we need to process another request from the client. Read data from the pipe and temporary variable. Pipe have good things for V, because we can read data from the pipe but don't use it, only read, process and keep it in the pipe. In the socket, if we read data from the socket, this data lost from the socket, and it's if we don't save it in the memory, this data is lost. But in the pipe we must call and tell the pipe delete this data. It's good feature, because if you use the SSL we need to check the 3 bytes from the beginning of the connection, and if we check the 3 byte from begin, we lost this 3 byte and we cannot handle the SSL connection. I explain it in the another videos. So we read data from the pipe and try to parse it. In the trace parse, we have a request, by default is null, and we need to know how many of data from the pipe we use it. Okay, we create a byte reader and read to /r/n/r/n. Why? Because HTTP have a request line and headers line. Request line is a method, a pass, and version, and a header name, a space, and data, and empty line after this body. We can have many header, but we have only one request line. So for example, get /http1, it's uppercase but I write it in lowercase. For example, us, and for example, this is like, it's the simple HTTP request. So we write to this because each line in HTTP1 have a CLRF encoding. CLRF is CRLF is /r/n for each next line. In the LF we use /n only, but in CRLF we use /r/n. So we write to /r/n because we have a next line in the end of headers and next line in we have a next line for each header and next line for end of header. So we have a two next line and read it. We export the ASCII text from the binary data because HTTP1 is based on the is based on ASCII, not UTF-8, and parse the lines, split the parts, read the content, and default value for content length, because if we want to read the body we need to know we need to length of the body. Okay, and we create dictionary for headers, parse each header, and we need to know headers splitted by two dot and white space. So we read the 2 dots and it's not exist, skip the line, get the name of the header, back of the 2 line, and get the value +1 because we have a white space after that, and trim it for sure, and add this to the headers and if this header is a content length, we write it to a content length, and write the body from the content length, read the body from the content length, and consume it and create a HTTP request. What's the HTTP request? Method, path, version, headers, and body. So in this here we have all three parts. And something else, in the request line we have three parts, and each part is split it by white space. So for headers we do 2 dot and white space, but for request line we have only white space, and is every time is 3 parts, not more, not less. Okay, and for now we get the request. After the request we need to handle it, and we need to handle it. In the handle part we need to read the connection, because we are default on keep alive, but we need to know if the client do something else, we read it. And in the connection header we have a two value can be b. First of all keep alive, and second of all close. But in HTTP 1 by default connection is close, so we read if is keep alive, keep it alive, and if not HTTP 1 is HTTP 1.1, we need to write the close. It's in the header we don't have a close, it's keep alive. And why? Because we don't use the something else, because we can connection header does not exist. Some of times client don't send to the connection header, so we use like this, because if this not exist we only create a choice from the version. After that we write a simple response, only simple response. What's the response? In the HTTP we have a response like the request, we have a request line, response line, headers, and the body. So but response line in the response have a different type. First of all, in the request line we have at the last HTTP version, but in the response line we have a HTTP version at the first. We don't have a pass because it's not necessary, because it's the client to server, not the server to client. So in here we need to know how the request process it. If it's bit 2 it's okay, and it's 5 it's error in the server, it's 4 in the error in the client, it's 3 is the redirect, it's 1 and something else. And after the status code we have a message of status code. It's not necessary, but always is here. After this line we have a headers. For now we don't have a content length, but we need to tell the clients. We don't have a content length. We need to tell the client which server process it. It's not necessary, but we need to write it. In the RFC, we need to write the date of the process, the process time of date of now, and at the end we need to tell the client how connection process it. It's keep alive or close it. We can have another headers, but not necessary. And at the last, we create a byte array of this data and send it to a client. Okay, and test this. Test for preview of this. Okay, I test the server by K6. It's good. Okay, it's run. Okay. It's run and test it. K6 run. SCD K6 run a script and run it. And after the 10 seconds I break it. Okay, only 28 because my system in the Power Money server. Okay. Wait and wait and wait and wait. Okay, it's not bad. Sometimes because of my power management system, it's this many requests in seconds, and it's good for a simple HTTP server. Okay, I think it's enough for now. See you in the next video.